Hello and welcome. In today's video, we are going to talk about simplifying expressions that contain fractions by using the rule of BEDMAS. I hope that you are familiar with this notation. This is just an acronym that we use for the order of operations in simplifying expressions. It tells us that when we simplify n expressions, we must simplify inside the brackets first. Letter B stands for brackets, and then we must perform the powers or the exponents. We must divide or multiply, and last, add or subtract. Now, one thing that I want you to keep in mind when we are simplifying expressions that involve fractions is this. We can add and subtract fractions if and only if the denominators are the same. So, when we add or subtract, we must take care of the denominators. We must make the denominators the same. When we multiply or divide, we don't have to worry about the denominators. Okay? So very often I've seen people that when multiplying and dividing, they still want to make denominators same. Nothing wrong with that because it's going to work out anyways, but it's just unnecessary. So let's get started. In the first example, we have the fraction 1 over 3, brackets 1 over 2 minus 5 over 8. So we're going to start with brackets first. So we have brackets here, but there is nothing to simplify inside the brackets. And then we have this set of brackets here. Here we can simplify because we have two things subtracting. So what we're going to do is get started by working on the second bracket. You still need to write the first one, always write the equal sign, and always work vertically, because in this way you won't lose your terms as we move on from one step to the other. So in order to subtract these two fractions, remember that the denominators must be the same, we said. So in this case, the denominators are not the same. Just by inspecting here, you can see that one denominator is 2, the other is 8. The lowest common denominator must be the denominator for both fractions, right? In this case is 8. Which means that we have to change 1 over 2 into a fraction with denominator 8. And in order to do this, we are going to need to multiply number 2 by 4. And since we are increasing the denominator 4 times, we must increase the numerator 4 times so we maintain the same value of the fraction. Now the other term, minus 5 over 8, doesn't need to be altered. It's because the denominator is already 8. Moving on, we have 1 over 3, still there. And then we simplify the fraction here. That would become 1 times 4, which is 4, divided by 2 times 4, which is 8. And then minus 5 over 8. So again, 1 over 3. And now we are going to subtract fractions. Remember, in addition and subtraction, we keep the denominator the same. Nothing will happen to the denominator. We only operate with the numerator, so the numerators will be subtracted as indicated in this case, 4 minus 5 under 8. So whenever you make a change in a step, so here we are adding the fractions, for example, the next thing you want to do, or the next step would be simplify. So we have 1 over 3. 4 minus 5 is negative 1 over 8. Now it's time for us to multiply them. Again, do we need to make the denominators the same? No, because we are multiplying, and when we multiply the numerators together, and the denominators together. Okay? That's the way it works. So we're going to say this is 1 times negative 1 divided by 3 times 8, which in the end will give us 1 times negative 1 divided by 3 times 8. Let me make this look better because it doesn't look that great. Divided by 24. And this will be the final answer. I'm going to move on to the next question. And again, as I always mention to you when I explain something, go ahead, pause the video, and try to do things on your own. It's better to do something on your own, to attempt doing things independently and make a mistake and understand what the mistake is and fix it, than just looking at things and creating the impression that, oh, I understand, it makes sense. We learn best when we practice on our own. Here we go. 2 over 3 plus negative 3 over 35 divided by 1 over 5. A few problems that we need to, or a few things that we need to take care of in here. Number one thing, you see how we have a plus in here and a minus in here? This just looks awkward in an expression, so we don't want to have plus and a minus. So we make them into one single sign. So a plus and a minus, we know, will make a minus. So we'll rewrite the expression as 2 over 3, and instead of writing plus minus 3 over 35, we'll simply write minus 3 over 35. Another thing we need to take care of in here is this number. When we're operating with fractions, we need to have the numbers in the same shape. So the fractions in the same shape. And what we have in here is a proper fraction, 2 over 3, a proper fraction, 3 over 35, and this is a mixed number. The numbers need to be in the same shape for them to communicate with each other, to talk to each other. So we're going to convert the mixed number into a fraction. And remember how we do this. This way we multiply, this way we add. So 5 times 1, 5, plus 1, 6. And denominator stays the same. Now the next thing that we want to do is take a look at what we have and see what operations we have between fractions. So we have a fraction, a fraction, a fraction, subtraction, division. Guess what's going to come first? Division. So we're going to say that we have 2 over 3, and then minus, and then 3 over 35. Remember how we divide two fractions. The division will change to become a multiplication. And that will automatically change this number that is coming after the division to the reversed number, which means number 6 over 5 will become 5 over 6. So these two operations happen simultaneously. So the division turning into multiplication will make the fraction coming after it flip. So now this looks a little bit cleaner and neater, and we're going to say that we have to perform division based on the order here, right? So division, and then we can do the subtraction, which is at the very end. So we have 2 over 3, oops. And then when we divide a negative by a positive, we get a negative number, so don't be afraid of this negative. Or when you multiply, it doesn't really matter. So we have in here 3 times 5 over 35 times 6. Now, some of you are probably thinking, wait a second, there are things that I can do in here before I decide to multiply these numbers. And if you're one of those people, then probably you know your math very well. So what we are going to do here is check and see if we can reduce the numbers. Remember, the operation between the terms is multiplication. And that means that all these are factors in here. A factor, a factor, a factor, a factor. And in a fraction, we can always simplify factors. Factors simplify each other. So number 3 will simplify number 6. So 3 divided by 3 is 1. 6 divided by 3 will be 2. On the other hand, number 5 will simplify 35. 5 divided by 5 is 1. 35 divided by 5 is 7. And then we're going to say that we are left with 2 over 3, which was our first term, and then minus. Here we have 1 times 1, which is 1, divided by 7 times 2, which is 14. So we have 2/3 minus 1 over 14. We need to find the lowest common denominator to be able to subtract. So since 3 and 14 don't have any factors in common, any prime factors in common, then the lowest common denominator will be the product of the two. So that would be 42. So we need to change number 3 into a 42, and we need to change 14 into a 42. So we need to multiply 14 by 3, and we need to multiply number 3 by 14 to make this happen. So here we go again. 14 times 2, we need to simplify each fraction. 28 over 42 minus 3 over 42. And we keep the denominator the same, 42. And we only work out the numerators, 28 minus 3. The answer will be 25 divided by 42. We check and see if we can reduce by anything, but in this case we can't. 25 only has factors of 5, and 42 doesn't have a 5 as a factor. So this would be our final answer. Now, going back to the solution, okay, and whenever you look at or you just see a certain way of presenting a solution, and you find that there is a step that it was a bit vague and couldn't understand, you can read it one more time if you wish, okay, and see if it makes better sense. And in my opinion, when I look back at this, I would say that maybe this one here didn't make a lot of sense. Okay, so I'm going to try to do this a little bit differently. So I'm going to use a different method to simplifying that, just to reach out to the people that probably weren't too sure about how this one worked. So I'm going to start from here. So remember, here we have 2 over 3 minus 3 times 5 over 35 times 6. Okay, so that's 2 over 3 minus, I'm going to go straight ahead and multiply in here. That's the easiest thing to understand or to see here. So 15. And 35 times 6, well, 2 35s will make a 70, so that's 210. If you go this way, that's totally fine, and that's the beauty of math. We can do things in different ways and still get the same answer. But what do we do from here? So how do we find the lowest common denominator? This is quite a big number. We don't like very big numbers. So what you want to do, or what you want to try to do, before you start looking for lowest common denominator, is check and see if you can reduce the fractions, or any of the fractions, or check all of them. In this case, these two can be reduced both by 15, right? Because they're divisible by 15. So then you get 2 over 3 minus 1 over 210 divided by 15 is equal to 14. And you see how you end up with the same idea as in here. So you end up with 1 over 14, and the rest of the solution will continue to go this way around. Okay? Could I take a look at another example? In this example, we have too many fractions involved, and we have fractions inside fractions. So the first thing I want to do is try to sort them out a little bit. The main fraction here is this big one. So what we have in here is this fraction added to this one here, and then divided by this single fraction. So I hope this looks a little bit clearer now, or better. And what I'm going to do is I will draw my big red fraction first, fraction line. And I am going to simplify the numerator. You see, you need to add two fractions, but they don't have the same denominator. So we have to find the lowest common denominator of these two first. So lowest common denominator here will be 15. They're both prime numbers. 5 and 3 are prime numbers. So lowest common 15, the product. And I'm going to think again, negative 3 over 5 must have a denominator of 15, so multiply by 3, top and bottom. On the other hand, 4 over 3 must have a denominator of 15 as well, so multiply by 3 over 3. Sorry, where are we? 5 over 5, goodness. What a great teacher I am, huh? Okay, sorry about that. So the next one is denominator negative 5 over 6, but we don't have to do anything about it because it's in the denominator of the big fraction. So now we have to simplify each fraction in the numerator. So we have negative 9 over 15 plus 20. So these two multiply each other over 15. And then everything over negative 5 over 6. We still have work to do in the numerator here. So let's bring them together. We have the big red fraction and negative 9 plus 20 over 15 divided by negative 5 over 6. I know that I'm going through too many details probably. If you are wondering whether you can go from, let's say for example, this step to the one I'm going to write now, the answer is totally normal. So negative 9 plus 20 would be 11 over 15. Nothing to reduce. 11 is a prime number. Over negative 5 over 6. So here we are in a situation where we are trying to divide a fraction by another fraction. Remember that to divide two fractions, we're going to take the numerator, so the first number, write that down first, and then change the division into a multiplication, and then the denominator got to flip around, so reverse it. So that will change to become 6 over 5. Now wait a second. You see how you have a negative here. So the negative can go either here or here. It doesn't really matter where you put it. So not to confuse anything, I'm going to leave it with negative 5 here. And we have 11 times 6 over 15 times negative 5. Okay? So there is multiplication in between. That would be 66 divided by 15 times 5 is 75. negatives. You have to check and see if you can reduce if possible. So it seems that we can in here. You reduce by 3, and the answer here would be 22 divided by 25. And since we have a negative sign in here, that means that the answer will be negative. Let me write this a bit better. The answer will be negative. So negative 22 over 25 will be the answer to this question. Okay? So in the next example, we have negative 2 over 3 plus negative 1 over 4 divided by negative 1/2 plus 1. So I'm going to pay attention to brackets first because they must be done first. So we have a bracket here. But when I look at it, there is nothing that I can simplify, meaning adding, subtracting, so nothing to do inside these brackets. And we have these brackets in here. And in this bracket we have 2 terms, so which means we need to simplify this first. So that's where you start from. Always have the bigger picture of the question, so have a full view of the question. So we have negative 2 over 3. The plus and the minus, always take care of this. Why not? As you are simplifying other stuff. This 2 will make a negative. Divided by, we need this fraction still, okay? Because we have things going on inside the brackets and we're taking care of it. Now, we have to add these 2 numbers. I'll make them fractions so that it's easier for me to see them. So we have negative 1 over 2 plus 1 over 1. Now the lowest common denominator here will be 2, which means I need to write this as a fraction with denominator 2. And then we have negative 2 over 3 minus 1 over 4 divide by, open brackets, negative 1 over 2 plus 2 over 2. We're not done with brackets yet. There is still things that we can simplify. So this would be negative 1 plus 2 divided by 2. So negative 2 over 3 minus 1 over 4 divide by, finally we're done with this, 1 over 2, right? And moving on, somewhere here, we need to take care of the next thing, exponents. We don't have any. Division, yes, we do have one, so we'll take care of division now. So we have 2 over 3 negative minus 1 over 4, nothing changes so far. Now the division will switch to multiplication, and the number after the division, the 1 over 2, will change to become 2 over 1. So we have negative 2 over 3 minus 1 times 2 over 4 times 1. I know you can do this in your head, and that's what you're supposed to do. I'm just showing the work in here. So negative 2 over 4. Even better, negative 2 over 3 minus 1 over 2. So we're reducing this by 2. And now we multiply this by 2, this by 3, to make the denominator equal to 6. Otherwise, we cannot subtract them. So that would be negative 2 times 2, 4. Negative 4 over 6. 1 times 3, 3 over 6. So denominator is the same, 6. Negative 4 minus 3 will be in the numerator. That's negative 7 divided by 6. And this is the final answer. Voila! I'm going to take a look at the other two examples that I selected in a different video. Okay? If you want to, go ahead and try to do them on your own. Thank you for listening, and bye for